Okay, so hello. This is the milestone 2 of our project, and today we're going to see how we we made the whole process for the cylinder. So first, remember that in last video we chose letter C, which was for cylinder, and we created a file stream called figures, and then we had a name specific for this file, which is the one of a cylinder. So we open it and we start our program. So we declare the variables that we're going to need, that is height, radius, and the radius negative. Okay, so now we ask the user for the height and the radius, and we specified in millimeters because that's the measurement we want. And both variables enter in height and radius in radius. And then we ask the user that if the radius is bigger to the size, the radius and the height are bigger than the sizes that we can print for the coordinates, that they try again and enter the measurements again. But if the measurements are correct, now we multiply the radius times -1 to get the radius negative, and we initialize the variable z to 0. So now to get the coordinates, first we get we make a float for the y, for the part for the upper part. So we use the formula, which is, well, no, first we start in x radius negative to x radius, and it goes adding 1 by 1 in x. And then we use y equals to the square root of radius to the square minus x to the square, which is the formula of a half circle. And then we round it, so we save the variable in y. And then that's for the values upper. And then for the negative values, we use the same, but we start in radius -1 because we already had a point in radius, until radius negative, and now we're decreasing x in 1 by 1. And we use the same formula, square root of radius to the square minus x to the square, just now we multiply it times -1. Same, we round it and we save it. And then when we have the x coordinates and the y coordinates for the base, we begin going up, and that's why z starts increasing. And we do all this while the variable z doesn't equal the height. And that is all for the cylinder. Then when you run the program, let's run it. And so let's see, 300 and 200. And then the program is going to be saved as here we can see it, as a cylinder.csv, and then we can open the program, and then we can graph it and know that it's correct or it's incorrect and the changes that we need to make. And that's all for the cylinder.